In this video, we are going to focus on improper integrals. You will find this on page 338 in the Namibian AS-Level Mathematics textbook y equals mx plus c to success. Improper integrals. An integral of the form this, infinity a fx, or b, negative infinity fx, or positive infinity, negative infinity to the function is called an improper integral. So basically, as soon as you see the infinity sign, it's an improper integral. The upper limiter of infinity, the lower limit of negative infinity, or both, is what makes these integrals improper. Before we investigate improper integrals, let's first see how the infinite sign is used in calculations. Now, this is actually a very difficult concept, especially in this level. I think it's more after school that you will encounter this, but just because this is in the syllabus, I must show you a little bit more before we go to improper integrals. Okay, so let's first look at the infinity sign. Using the infinity sign in calculations. Now, infinity is the idea of something that has no end. It's just going on and on and on. But to explain the basic operation, plus, minus, multiply, divide, we will say that positive infinity represents a really, really large positive number, and negative infinity represents a really, really large negative number. But remember, infinity is not a number, a symbol, and so it's not a number and generally does not behave like a number. It's really just to show you the calculations and to understand the calculations. So if you have x plus infinity, so it will just be infinity. This is not negative. Okay, so 2 plus infinity will just be infinity. Do you see? So a positive number plus it is just positive infinity. If you have a number plus negative infinity, it's negative to the negative infinity. So 2 plus negative infinity is negative infinity. Okay. Infinity plus infinity stays infinity. It's not 2. It's not like x plus x, it's 2x. No, it stays infinity. Just that. Just one infinity, if you want to say it like that. So any positive number added to a really, really large positive number or really, really large negative number, regardless of the sign, is still a really, really large positive or really, really large negative. Okay, so it's just staying that. No, that's for addition. Now subtraction is more or less the same. Okay, so x minus infinity is just now negative infinity. Okay, so 2 minus negative. Okay, but if you have x and you have that minus and then negative, then it also becomes a positive infinity. Okay, so this is positive. And a negative just stay negative infinity, not negative to infinity, not correct. So a really large positive number or really large negative number, regardless, subtract from a positive, is still a really, really large. Okay, so it's more or less the same. If it's positive, it stays positive. It's negative, it stays negative. It's just, and you can just work with the signs there that it became a positive. Okay, now let's look at multiplication and division by infinity. And I'm just going to move it a little bit out. Multiplication by infinity. Okay, so if x is bigger than 0, so it's a positive number. So x multiplied positive it stays positive infinity, like this. It's better to see a number, to put a number in the place of x. This is multiply negative, it's negative infinity. And negative times, if x is smaller than 0, so it's like negative 2. So do you see? Then it's negative infinity. It's almost like working with the signs. The negative and the negative is positive. So just like we did there with the signs, this is the same principle counts here. Okay. So that's negative, that's negative. So it's just working with that sign. In division, now this is very important, division. So it depends where's the infinity. Is it in the numerator or is it in the denominator? Okay, but now in the denominator is the number. Okay, so if infinity divide by 2, a number, 3, 4, it's infinity. Negative, so infinity divides by 2, it will be negative infinity. Okay, do you see that? Okay, so if it's positive, it stays positive, but it stays infinity. Okay, I could have actually, and I think maybe I must do it, just say the negative infinity divides by 2, and then it will be negative. I could have just put that example also for you. Okay, when the number is smaller than 0, okay, now infinity divided by like negative 2, and again it's that signs, do you see? This is going to be a positive, okay? And that was positive. And negative divided by a negative, that will, it's again the signs, it's a positive. Do you see? So if I say, okay, it seems to me I was showing you the negative one. So if I was showing you this one, divide negative 2, then it's just negative infinity. So look at the signs. But if the infinity is on top, the number at the bottom, it's infinity. And now is the one I want you to check. If the number is on top in the numerator and the infinity is in the denominator, then it's going to become 0. Do you see? So 2 divided by infinity is 0. 2 divided by negative infinity is 0. And for me, this is very important because most of the time the infinity, it was just infinity, but here it's 0. I just think I only want to make yellow. Do you see? So this is very important for me. When the infinity is in the denominator and also in the calculations, remember that. Okay. So, and this is just explaining that, and I just want to read this division to you. A really large number, positive or negative, divided by any regardless is still infinity. That's the top. But a number divided by a really large number, positive or negative, tends to 0. Okay, so that's where the difference comes in. Very important, in the undefined operation, positive and negative is undefined. Okay, or infinity divide is undefined. Okay, so just keep that also in mind. Okay, now we come to improper integrals. Improper integrals are said to be if it's convergent, if the limit exists and it is a finite number. Exists, not so it's not infinity. So there's a number, okay. So there's a specific number. We can calculate the integral. And if it's divergent, if the limit does not exist, okay, so it's an infinity, it's giving you an infinity answer, we cannot calculate. So here we can calculate a number, here we cannot, it's just the infinity sign. We will study 2 different types of improper integrals. The infinite interval or the discontinuous integrand. Okay, so but let's first look at the infinite interval. Now, if you look in this kind of integrals, one or both of the limits of integration are infinite. In these cases, the interval or integration is said to be over an infinite interval. Okay, do you see? They're both. I want to make it a little bit bigger. Okay, so do you see in this case? No, in this case, and this is good, I make it bigger. There's the infinite, there's a number. We will replace the infinite sign with a variable, t, finite value. Find the integral and then determine the limit of the result as t tends to infinity, providing the limit exists. And if the infinite sign is here at the bottom, we will place the infinite sign again with the variable, find the integral and then determine the limit of the result as t tends to negative. So there it was just positive, there it's on top, negative provides the limit exists. Wow, I said so many things. I think now it's just important that I look at an example and give you an example. let's just move it up a little bit. It's infinite signs is very small. Okay, if I say evaluate the following integral, there's the infinite sign, there's 1, there's the function, and determine whether it's convergent or divergent. Okay, now very important, let me just take you back there. There, it's if we get a number, it's convergent, and if we don't, if we just get an inequality, an infinite sign, then it's divergent. Okay, so keep that in mind. Let's look at this example. Okay, there. Okay, evaluate the following, okay, and determine whether it's convergent or divergent. Okay. Remember what I said? The first, write the integral with an upper limit t. In the place of the infinite sign, just go and put a t, the variable t. Now just do integration, exactly, and then substitute. And now just look at this step. I just want to show you. This is going to be negative 1 over t, and this is going to become negative, and this is going to become, okay, let's just see, this is 1, because it's going to become negative 1, okay, so because it's going to be anything to power, it stays 1, and there's the negative 1, and then it's going to give me that 1, I just swapped the two sides, okay. Now this step is very important. So as t tends to infinity, so 1 over t, and now you have to look back on your list, and if I'm going to take you back, 1, like 2, over infinity is 0. Do you see that? That was very important. Okay? So, so that is 0. Okay? So in this case, this whole thing is going to become 0. But that first one was just 1. So it's 1 minus 0. So I have a number. I have a value. So hence the improper integral has a finite value of 1, a number. And therefore, the integral is convergent. Okay, I want you to stop the video, and I want you just to do number A and number C. I'm just going to make it a bit bigger. You can see all that signs. Okay. And then I'm just going to say number A. Let's start. Stop the video, try your best, go back, memorize a few things, and then after that, because it's not very difficult. I think it's more the principle and some of the new things, the infinite sign, that can be challenging. Okay, but in this case, it's going to be like this. And read the question. Determine whether the following integral is convergent or divergent. Okay, then you must think infinities, and you see the infinity. If it's convergent, find its value, because then there will be a value. Okay, I think you already wrote it down, so I'm going to make it a bit smaller to give myself space. Okay, I'm just going to get it ready for integration. Oh, time is not looking nice. Now I'm just going to put this. So if I'm going to, no, let's first start with it better. I'm going to rather put, first in the place of the infinity sign, I'm going to put that t. And now I'm going to integrate. So it's 3x, if I add 1, so it's minus 1, divide minus 1, and my boundaries are t and 1. Okay. Then I'm going to substitute. So in the place, this is, it's actually, I'm going to write it here. It's just going to be negative 3, do you agree? And this x is just going to come down. Okay, and it's t and 1. Now I can substitute. So it's negative 3, and I first substitute the t. And then I say -3 and I substitute the 1. And that's -3 over t plus 3. Okay, but this step is very important. You say as t tends to infinity, striving to infinity, then -3 over t is then that -3 over infinity. And don't forget, I'm even going to take you back again. Oh, take two back. Do you see? As soon as you're over infinity, did you see there? Then it's always just going to become 0. Okay? And that's going to strive to 0. And now I'm just going to substitute that. So therefore, I'm back at the, to move this, the original one. It's going to get that -3 to infinity plus 3, but -3 to infinity is 0 plus 3, and that will give you 3. Do you agree? And then I end nicely by statement. Just end with it. Therefore, or hinge, if I say hinge, and because I'm very that you write it technically correct, so don't put the therefore then. Hinge the improper integral has a finite value of 3 and is therefore convergent. Because that was the question. Find the value and say if it's convergent or divergent. Okay, let's look at number C. When I was looking at number C, I realized that, say there's the number line, there's -2, and I'm talking about infinity, then if it was positive infinity, it would have been to this side. So because I wrote the -2 on top, then this must be negative infinity. So they must not stand in positive, they must stand in negative infinity. And I will correct it in the final version of the book. So if it was confusing to you, you can first stop the video and redo it, and then as soon as you are finished, you can continue the video. Okay. But let's write it down. So there's -2, and this should have just been negative infinity. It's not going to influence a lot of your calculations. I'll just show you. Instead of positive, you just write negative. Okay. So I'm going to make now that t, can write it here, is now negative infinity. So I'm going to say -2, and I'm going to put my t there. I'm going to get it ready to integrate. So take it up, and I'm going to integrate to x. Okay, now I can start. So if I'm going to integrate, I'm going to say 10x. If I add 1, it's -2. I divide by -2, and I'm going to write -2, and now it's t. Okay. And now I'm just going to simplify it. So this is going to be -5. Do you agree? -5 over x squared. And I'm going to substitute, so it's -5, and then it's -2 squared minus -5 then t squared. And then I'm closing. And that will give me an answer of negative 5 over 4, that becomes positive, plus, because there, 5 over t squared. Okay, so now we're going to say as t tends to negative infinity, is what we wrote there, we are going to say that 5 over t squared tends to 5 over negative infinity squared. Now remember, negative infinity, it's going to be negative infinity multiply negative infinity. And I want to take you back and show you what is that. And you see, if you have negative times negative, it's positive infinity. So that is going to give you, that tends to 5 over positive infinity. Okay, and that tends to 0. So we are going to say, therefore, I just want to finish there, that was positive infinity. So therefore, now we're just going to say negative 2, negative infinity, 10 over x free dx equals negative 5 over 4 plus 5 over positive infinity, which will give me negative 5 over 4 plus 0, and that is negative 5 over 4, or negative 1 1/4. So I'm ending up by saying, hence, the improper integral has a finite value of, let's just move it up a little bit, of negative 5 over 4, and is therefore, and here comes the word, convergent. Okay, that's how you do it.